Hello, my name is PJ. Occasionally, I have to make demo or training videos. Over the past year, I've gotten increasingly frustrated with my process for producing these, so I decided to finally do something about it. So what's the problem? If you want the presentation's audio to sound decent, you need a quiet room, a microphone, and no background noise. Then you record your script, stumble over a word, do another take, and another. Eventually, you get something usable. But here's the part that really got to me. A week later, you need to update that video. Maybe the API changed, or you found a better way to explain something. You either re-record the whole thing or splice in a new section that never quite matches. The tone is different, the room sounds different. I kept putting off updates because the re-recording took longer than the actual change. So in my free time, I built this thing called deck2video. The idea is simple. You write your presentation in Markdown using Marp or Slidev, put your narration in the speaker notes as HTML comments, and run a single command. It auto-detects which format you're using. The tool spits out an MP4 with narration in your own voice, and if you need to change something, you can edit the text and just regenerate the MP4. And all of this can run locally on your laptop. I looked at 11 labs and similar services first. They're good, but they charge per character, which adds up if you're regenerating often. And your scripts go to their servers, which complicates things when proprietary information is involved. So I went with Chatterbox TTS instead. It's MIT licensed, and it runs entirely on your own machine. One benefit of this approach is that everything lives in a single Markdown file. Slides, speaker notes, all of it. It diffs cleanly in Git, so you can review changes in a pull request. Someone fixes a factual error in a speaker note, that's a one-line diff. The MP4 is just a build artifact. You could regenerate videos in CI if you wanted to, and because it's plain text, you can feed it straight into a RAG pipeline. An LLM can index it, search it, answer questions about it. With a video or a PowerPoint, you need to transcribe audio or extract text from images. Markdown is already plain text. Web content accessibility guidelines require text alternatives for multimedia, which usually means someone has to go back and caption the video after the fact. It's tedious, so it often doesn't happen. But with this approach, you wrote the transcript first. The text alternative exists before the video does. Under the hood, it's a 4-stage pipeline with an automatic format detection step up front. The tool looks at your front matter and directive comments to figure out whether you're using Marp or Slidev. Then it parses the Markdown, renders slides as PNGs with the appropriate CLI, synthesizes audio with Chatterbox TTS, and stitches it all together with ffmpeg. If you give it a short sample of your voice, the TTS clones you. It's not perfect, but it's surprisingly good. Let me walk through each stage. Parsing is the boring part. Split on triple dash delimiters, skip the YAML front matter, pull out HTML comments as speaker notes. There are separate parsers for Marp and Slidev because they handle metadata differently. Marp uses HTML comments for directives like _class or _paginate, so those get filtered out. Slidev uses per slide front matter blocks, so those get stripped instead. Either way, what you're left with is a list of slide data classes. Rendering is a sub-process call to the appropriate CLI. For Marp, it's Marp CLI. For Slidev, it's the Slidev CLI's export command. Both check for a global install first, then fall back to NPX. PNG output gets us 1920 by 1080 images. There's a sanity check. If the parser found 12 slides but the renderer only produced 11 images, we bail out. Better to stop here than produce a video where slide 7's audio plays over slide 8's image. This is the slow part. Chatterbox is a neural TTS model that runs on your local GPU or CPU. You give it a wave sample of your voice, and it clones you. Each chunk comes back as a tensor. We concatenate them with torch.cat, one wave per slide. Slides with no speaker notes get a silent wave, just a riff header and zeroed samples. Oh, and if it mispronounces something, you can add a pronunciation override file. It's just a JSON file that maps words to phonetic spellings. Last stage. Each slide becomes an MPEG transport stream segment. The PNG loops as video frames for the duration of that slide's audio. We use x264 with the still image tuning flag, so the encoder figures out that every frame is identical and the bitrate drops to almost nothing. Images get scaled and padded to 1920 by 1080. Audio is encoded as 192 kilobits per second, AAC. Then ffmpeg joins all the segments. That last step is a stream copy. No re-encoding, takes a couple of seconds. Not every slide is a static image. If you need to show a screen recording, a terminal session, or a product demo, you can embed a video file directly into a slide. Just add a video directive as an HTML comment with the path to the file. The tool strips the screencast's audio and replaces it with the TTS narration from your speaker notes, same as any other slide. If your narration runs longer than the video, the last frame freezes until the audio finishes. The output frame rate automatically matches the highest frame rate among your screencasts, so a 60 frames per second recording stays smooth. You can override this with the FPS flag if you want. Everything goes into one temp directory: PNGs, WAVs, transport stream segments, all of it. If a stage fails, that directory sticks around so you can see where things stopped. On success, it gets cleaned up, unless you pass a keep temp flag. For the reference sample for voice cloning, you can record 5 to 10 minutes of yourself reading varied content, different emotions, different pacing. I actually booked an hour at a recording studio to do this, so I get the best quality sample possible. Then point it at your slide deck, pass in your voice file, and a couple of minutes later you get an MP4. There are flags to tune expressiveness and cloning fidelity. I'll be using this for demos and training videos, but with a for loop and a folder of Markdown files, you could easily use this to build a YouTube empire of 10,000 AI-narrated brain rot videos. I'm not going to do that, probably. So, full disclosure, this presentation was generated with deck2video, and you can almost certainly tell the cadence is a little off. Some words land weird, but it still sounds better than what I would have actually recorded, which would be full of ums and ahs, pops, and breath sounds. The whole thing is a single Markdown file. If I needed to fix something, I'd edit the text and regenerate. The real me is probably getting coffee right now. So here's the actual time breakdown. 1 hour at Q Recording Studios in Falls Church, Virginia, getting a studio quality recording of my voice. That cost $85. 2.5 hours with Claude Code, building the entire pipeline, start to finish. And about 30 minutes writing this presentation, mostly just editing text files in Vim with Claude helping. Then, I kicked off the generation and walked away. That's it. The repo is on GitHub if you want to try it. I'm happy to walk through the setup or answer questions. Thank you for your time.